All right, good morning. Today we are going to look at more squares and side lengths and area for that. I want to come back to those squares flashcards we talked about a little while ago. Started doing a little bit last week or the week before even. So we're going to start off with a few warm-up questions. How do you find the area of a square? Think about how did we find area of a square if we knew something about it. What is the formula? Is there a formula for the area of a square? Let's go backwards. If we knew that area, how could I figure out the side length? So take this time on your task statement Google Doc to try to jot down an answer to a couple of those if you have anything for that. Otherwise, I'll go over that. You can just jot it down on your own. So the area of a square is basically just a rectangle. But the special thing about the square is that it has all four of the same side lengths. So we can find the area by doing the side length times side. Let's see, multiply the side length times the side length. So then, is there a formula for this? Well, yes, there is obviously a formula for this. And you're probably familiar with area equals length times width for a rectangle. But in a square, length and width are the same. So length equals width. So we just call it S for side. And area is side length squared. I can get the exponent by doing command dot on a Mac. You can get it by, I just searched the help for SUPERS, there it is, superscript. If it's a shortcut for your computer, it'll probably tell you what it is, or you can just click it and it'll get you superscript. All right. You could also just write area equals S, and then above the 6, there's a little arrow pointing upward. That could also be used to mean exponent, or area equals S squared. So that's how I would find the area of a square. That's my formula. I could also say up here, I could do the side length squared, or times itself. And if I know the area of a square, how could I figure out the side length? So that's really our goal question for today, is to really get a good answer for this. And by the end of the video, we will have a really good answer for this. And the goal of it is to really work backwards. So for example, if I have a square that is 4 square feet, how wide is it? And we have to ask ourselves, what times itself equals 4? Or what squared equals 4? So if you remember those perfect squares and perfect cubes we were doing before, that might be very beneficial to you for some of these, especially as the numbers get larger. Because we should be able to figure out that 2 times 2 is 4, or that 2 squared is 4. So we know that our side length is 2. If we have bigger numbers, like let's say if I have a square. Okay, so now what if I have a square that is 144 square feet? How wide is that? Now that one's a larger number than 4, so it might not be obvious to figure out what number would I have to square to get me 144. But if we know our perfect squares, we should know what number times itself gets you 144. So think about that for a minute. What number times itself gets you 144? So you could run through a bunch of options. You could even try multiplying things out. You could try like 10 times 10 is 100. So that's too small. It has to be more than 10. Let's try 11 times 11. 11 times 11, well, that gives you 121. Let's try 12. 12 times 12. If you know your 12s tables, you know that that actually is 144. So really, since 12 squared gets us 144, we know this square must be 12 units wide. All right? So we're going to try a couple of these. Actually, before we do that, I'm going to introduce a word to you. So if you know the area and have to go back to find the side length, we want to answer this question. We want to answer what squared gets me 144. So if I know that 12 squared is 144, if I know that 12 squared is 144, that tells me something else. That tells me that, I don't know if you know this symbol, the square root of 144 equals 12. So that's read as the square root, I spelled square wrong, of course. The square root of 144 equals 12. And the square root basically just means the number that multiplies by itself to get whatever that number is. In this case, it's 144. So the number that multiplies by itself to get 144. And that number is 12. All right, so it's kind of like going backwards from squares. 12 squared is 144 because the square root of 144 is 12. But we could also say that the square root of 144 is 12 because 12 times 12 is 144. There's also a square root button on your calculators, either on your phone or your Desmos calculator. If you're stuck, it's not really supposed to be a calculator lesson though. We'll really look more at that later. If you know how to use it, you know. If you don't, we'll learn how to use it soon. But we're going to spend a lot of this week really getting used to what is a square, what is a square root. It's our goal of this week. I don't think it's a bad goal. I think it's a pretty reasonable expectation. So we're going to look below the table, and I'm going to just put this on a new page just so that it'll all fit. I'll put it in the page break. Okay. So we're going to complete some missing side lengths and areas. So we have a couple tables, and we want to know if my side length is 0.5, what's my area? So I'll do one of these before you, and then I'll pause it, and you can try to do whatever you can for the rest. So if my side length is 0.5, my area is going to be 0.5 squared. Oh geez, what happened? Squared. Oops, happened again. Okay, 0.5 squared. So that's my area with a side length of 0. And 0.5 squared is, and again, we're going to multiply this out on paper, all right? You want to do 0.5 times 0.5 like the old-fashioned way. I did it in grade school. Or just know that a half times a half is going to end up giving you 0.25. All right? So there's that one. You're going to multiply. If you know the side length, you're going to figure out the side length squared. I'll put that in red just so you know that's our new one. Red. And let's pick a different one. Let's say we know that the area is, oh, hold on, I gotta fix this table. Hold on. I had to change the numbers on the rest of the table. So yeah, let's start with one of the area ones now. So if I pick my area, and let's just say my area is going to be 36. So if I want to find the side length, I want to find the number what times itself gets me 36. So what number times itself gets you 36? Let's see, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So if you do 6 times 6, you get 36. So the answer is 6. because 6 times 6 equals 36. All right. Yeah. Or you could say the square root of 36 equals 6. That's really how I'm going to find it, saying the square root of 36 equals 6. I guess I'll put that in red, because that's like really the good part. All right, so the square root of 36 is 6. So I want you to try to fill in the rest of this table as well as you can. And if you only want to type in like just the number you get, or just the area, go ahead and do that. And then we'll see what the entire table looks like filled in just a second. Okay, we filled our table in. It looks like a positive checkerboard of numbers, so let's keep following through. So our side length, we know our side lengths. We just multiply it by itself to get the area. So 1.5 times 1.5 is 2.25, 2.5 times 2.25, 6.25. Just a lot of multiplication. Notice they all end in 0.25. And that has to do with the fact that a half times a half is a quarter. It's always going to end up in your answer somewhere. So we get these numbers: 2 1/4, 6 1/4, 12 1/4, 20 1/4. Yeah, these are our areas if our side length is like 7 1/2. Not whole numbers, huh? And then if our area was 1, our side length was 1. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Square root of 36 is 6. Square root of 47 is 7. And the square root of 64 is 8. And that's all because, again, 8 times 8 is 64. 7 times 7 is 49. These numbers are all examples of your perfect squares. So we can write the area of a square two ways. We can say area is side squared, or we can say that the side length is the square root of the area. So let's think about this. If a square has an area of 45 units, what could its side length be? So what do you think? Take a minute to pause it and think of the answer. What do you think if a square has an area of 45 units, what could its side length be? And refer to the table if you need to. Approximate it. Give an approximation. So if you notice, 45 units, there's no number, or there's no integer that, like, blank times itself equals 45. Because I could do like 9 times 5, I could do 3 times 15, but I couldn't get anything times itself. Like 6 times 6 isn't close enough, 7 times 7 is too big. And we're going to use our perfect squares to help us approximate these numbers, these square roots. So basically, I'm looking for the square root of 45. This is something we should be able to do mentally. If you give me the calculator definition, that's not how we do it, so don't do that. But looking for the square root of 45, we want to look at, all right, well, my area, let's see, if my area was 49, my side length was 7. And if my area was 36, my side length was 6. So it has to be between 6 and 7, because 45 is between 6 squared and 7 squared, which is really 36 and 45. So it's between 6 and 7. So like, all right, maybe 6 1/2, 6 1/3, 6 3/4, whatever. Some number between 6 and 7. But we can actually get even better, because we have this information here. We know that 6 1/2 squared would be 42 1/4. So it has to be more than 6 1/2, because 6.5 squared is 42.25. So the side length is between 6.5 and 7 units. And honestly, that's a pretty good approximation right there, to be honest. That's very good. Because we now know that it's more than 6.5 but less than 7. That gives us a pretty good range, 6.6, 6.7. You can even approximate it more if you wanted to. You could, and we'll do it in later lessons, you could also figure out what 6.7 times 6.7 is and see how close that is. We're not going to do that now. You could do that, but at this point, you might as well just use the technology available to us. But it's just a good mental math strategy. The other thing we could be reasoning about is just the simple act of saying, well, it's between 6 and 7, because 36 is less than 45, and 45 is less than 49. So you could say the square root of 45 is between the square root of 36 and square root of 49. And let's think, which number, 36 or 49, is 45 closer to? So 45 is closer to 49. So the square root of 45 would have to be closer to the square root of 49, or 7. So it's between 6 and 7, but closer to 7. And this is really like the golden problem of the day, where we really want to get at it as far as square roots, approximating them. We want to be able to do the math of them, but we also really want to be able to approximate them and say, like, well, I don't know the actual number, but it's pretty close to this. And we're going to spend a couple days on this. So if you're getting lost here, like, that's okay. We really just want to make sure we know what a square root is today. Like, what do I mean when I'm saying square root? All right. So you can try a couple of these. If your bathroom's 80 square feet and has a square shape, what is its side length? And can you give an approximate area of a square that's 5.25 inches long without doing 5.5 squared? Try those, and let's go over them real quick. And you'll have just a couple very similar, quick, like exit slip type problems. All right? Good job. So for 4, 5, and 6, again, if you're still like struggling with these exact wordings, or if you're just getting used to the concept of square root, like, don't worry too much. Like, we're gonna figure it out. You're gonna be fine. But basically, if your bathroom is 80 square feet in a square shape, what approximates its side length? 80, we want to think about that. That's pretty close to 81. And from our table above, we know that, not from the table above, just from our knowledge of squares, we know that the square root of 81 is 9. Or we could also know that 9 squared, sorry, wrong one, 9 squared is 81. So since the square root of 80 is very close to 9, so since the square root of 80 is very close to 81, the square root of 80 is probably very close to the square root of 81, or 9. So it's probably about 8.9, because it's pretty close. And really, that's the best we can say right now is 80 is pretty close to 81, is probably about 8.9. All right. Can you give an approximate area of a square that is 5.25 inches long without doing 5.25 squared? And from our table here, this one is from the table, we know that 5 squared is 25, and we also know that 5.5 squared is 30.25. So 5.25 squared is probably between those two numbers, right? So it's probably right in between them. So I just picked the number right in between. It's around 27.5. Or you could have said 27. Maybe it's like 28, maybe 26, maybe it's 29. As long as it's between those two numbers is the kicker. All right? So between 25 and between 30.25 is your main goal for your answer there. Then down here, can you give an approximate side length of a square that's 10 inches long? That is 10 inches in area. Good grief. Fix that. Sorry. Without figuring out the square root of 10. So the square root of 10 is just a bit more than the square root of 9. So 10 is just a bit more than 9. And we know the square root of 9 is 3. because we know that 3 squared is 9. So the square root of 10 is just a bit more than 3. It's probably about 3.1. All right, because 3.1 times 3.1 is probably around 10, because 3 times 3 is 9. So just sort of to wrap up and to summarize, it's only this first bold part. The rest of this is repeat garbage. Don't look at that. So anyway, this first part, I'll do it all. This is just the bad formatting of everything else. Okay, so lesson 2 summary. So suppose we know the area of a square is 73. To find the side length of a square, we want to make sure that we know all the possible perfect squares or squares that have whole number side lengths. So we know that 8 squared is 64, and we know that 9 squared is 81. And 73 is between 64 and 81. So because we know that if the square's side length was 8, the area would be 64. So side length 8 means area equals 64, and side length of 9 means area equals 81. So we have to figure out what the side length is that gets us 73. So how am I going to get 73 out of here? Well, it has to be between 8 and 9, right? And really, if you're just at that point where you're getting the squares, cool. That's a pretty good start. We just want to make sure that we're thinking even more in the future about, all right, so between 8 and 9. But also, do you think it's closer to 8? Closer to 8, closer to 9, right in between. So 73 is pretty much right in between 64. 73 is 9 above 64, and it's 8 below 81. So it's really right in the middle. It's right in between 64 and 81. So I would just say an appropriate approximation is 8.5. 8.5 right in between. It's probably about 8.5 units wide. All right? And we could also call that number, very simply, the square root of 73. And that's our very exact answer. And 8.5 is our approximate answer. All right? But seriously, the goal, I really want you guys focusing on those squares and roots. If you get to the exit slip and you're like, I didn't understand any of that, I really want you guys trying out. I'm posting this at around 10 a.m. today, I think, because I want it to be after the live sessions. Try the squares and roots games on the 10 o'clock post. All right, it's going to go to a stream, not to the classroom. It's just a bunch of links. I highly recommend the Study Stack flashcards. And I also recommend what else do I recommend? What else is good? If you're also beginning out, you can try the matching game on Quizlet. Again, you're not supposed to sign into Quizlet, or I can't tell you to sign into Quizlet, just for various privacy laws. I mean, I've had kids in years past sign in, and I didn't know that was a privacy law, but this, you're not supposed to really sign in, or you don't have to sign in. I'm not going to tell you to sign in because I can't tell you to sign in, so you don't have to. The matching on Quizlet's good, but the Quizlet flashcards won't work for you if you're not signed in, so don't bother with that if you're not going to sign in. If you're getting more advanced or getting better, want to test yourself really well, you should try Gravity on Quizlet. It's actually a lot of fun. I've played it with kids in years past. We'll devote the day to playing, and I'll have it on the smartboard. We'll see if kids can get higher scores than me. We probably aren't going to be doing that, but we could try. My score's up there. You could see what my score is, and you can see what my other kids in years past scores have been. Again, you don't have to sign in to see the scores. Scores don't matter. All that matters is you. So just give it a try. Try one of those games. That's really going to be your main assignment for today/next days, since your exit slip is only a couple questions. All right. So good luck on all this, and thanks for watching.